For any help regarding solid mechanics assignment help, visit https://solidworksassignmenthelp.com. Email info@solidworksassignmenthelp.com or call us at +1 678 648 4277. Problems. Problem point 1. A closed can of soda is under pressure equivalent to that in an automobile tire. We measured the wall thickness in lab on Thursday to be 0.0025 inches. Estimate the axial stress sigma A and the hoop stress sigma theta, acting at a point in this closed, thin cylindrical shell, away from the ends. Problem point 2. Given the components of stress relative to an XY frame at a point in plane stress R, sigma x equals 6, sigma xy equals 4, sigma y equals -2. What are the components with respect to an axis system rotated 30 degrees, counterclockwise at the point? Determine the orientation of axis, which yields maximum yxy equals 4 and minimum normal stress components. What are their val xue's? Problem point 3. A thin-walled glass tube of radius r equals 1 inch, and wall thickness t equals 0.05 inches, is closed at both ends and contains a fluid under pressure, P equals 80 psi. SolidWorksAssignmentHelp.com. A torque, MT, of 300 inch lbs is applied about the axis of the tube. Compute the stress components relative to a coordinate frame with its x-axis in the direction of the tube's axis, its y-axis circumferentially directed and tangent to the surface. Determine the maximum tensile stress and the orientation of the plane upon which it acts. Problem point 4, potential quiz question. Find the axial stress acting in member EF of the end-loaded truss if its cross-sectional area is 0.1 in 2 and W equals 1,500 pounds. SolidWorksAssignmentHelp.com. Problem point 1. An automobile tire normally requires internal pressure from 24 to 36 psi. This pressure might be higher under certain situations. We will take an internal pressure as 32 psi for this problem. Let's say that a soda can have 3 inches diameter. We get that. Problem point 2. In this problem, you can solve it either using mathematical equation or drawing a Moore's circle. I will provide the mathematical solution here. Drawing a Moore's circle is an acceptable method and relatively easy and quick to do as well. The stress transformation equations. We get that when phi equals 30 degrees. SolidWorksAssignmentHelp.com. Solutions. Knowing that the shear stress component will vanish on planes that yield maximum and minimum normal stress components, we get that, so phi equals 22.5 degrees. Problem point 3. A thin-walled glass tube of radius r equals 1 inch and wall thickness t equals 0.05 inches is closed at both ends and contains a fluid under pressure, P equals 80 psi. A torque, MT, of 300 inch lbs is applied about the axis of the tube. Compute the stress components relative to a coordinate frame with its x-axis in the direction of the tube's axis, its y-axis circumferentially directed and tangent to the surface. Determine the maximum tensile stress and the orientation of the plane upon which it acts. SolidWorksAssignmentHelp.com. For this problem, we know that r equals 1 inch, t equals 0.05 inches, pi equals 80 psi, and mt equals 300 inch-pounds. Figure shows the sketch of the tube and an element subjected to the stresses caused by the internal pressure and the applied torque. If we assume the torque produces a force per unit length, Fr, uniformly distributed around the circumference, we have, from moment equilibrium about the axis of the can, mt equals 2 pi rfrr. Now if we also assume the force per unit length of the circumference is uniformly distributed across the thickness of the can, we have the axial stress and the hoop stress components are SolidWorksAssignmentHelp.com. From the stress transformation equations and the fact that the shear stress at the planes which have maximum and minimum normal stress is 0, we get that the extreme values for the tensile stresses, substituting into the transformation relationship for sigma and sigma y. Note the invariance of the sum of the normal stress components. Their sum equals 2400 psi. SolidWorksAssignmentHelp.com. Problem point 4, potential quiz question. Find the axial stress acting in member EF of the end-loaded truss if its cross-sectional area is 0.1 in 2 and W equals 1,500 pounds. We can solve this problem with but one isolation, as shown at the right. We want the force in member EF, so we take moments about PTB and require the resultant moment to be 0. This gives CW positive. And the axial stress is then 1500 / 0.1 equals 60,000 psi. So, SolidWorksAssignmentHelp.com